5x to the fourth plus 3x cubed minus 6x squared plus an x minus 8. That is a polynomial. Okay, but a binomial is a polynomial with two terms. Okay. So it specifically only has two terms, like 2x plus 7. The 2x is one term, the 7 is another term. And a trinomial is a polynomial then with three terms. So 4x squared minus 6x plus 1. Okay, like terms have the same variables and the same exponents. Those are key. They have to have both. If they don't have both, they are not like terms and you cannot combine them. So an example would be 5x cubed and 2x cubed are like terms. And can be added / subtracted. Then we have 6x squared and 3x cubed. These are not like terms because they don't have the same variable and exponent. And cannot be added or subtracted. Any questions over that? Okay, the degree of the polynomial is the largest exponent. The largest exponent is the degree of the polynomial. So if you have so 6x squared minus 7x to the fourth plus 2x cubed minus 10x plus 2. The degree is the largest exponent. Can someone tell me the largest exponent in this? Yep. 4 is the largest exponent, so the degree is 4. We don't care about the coefficients, the big numbers in front. We only care about the exponents, those little numbers above the variable. Okay, those are our exponents. Okay, standard form of a polynomial that is written in descending order of degree. So you have to have the biggest exponent first. Then the next biggest exponent, then the next biggest exponent. Because it starts with 3, then goes to 2, then goes to an exponent of 1, and then minus 1 doesn't have a variable, so it doesn't have the exponent. So it'd be a degree of 0. If I had something like this is not in standard form because my biggest exponent, the x squared, is in the middle and it should be at the beginning. Any questions over that? Okay, so now we're just going to simplify some polynomials. We'll start that first one, A. Okay, first thing we need to do is just combine like terms. You can see that it has a plus sign in the middle, so we are adding. That's the operation there. So we're just going to combine like terms. So the 2x squared and the x squared both have the same variable and exponent, so they're like terms. This is like there's a 1 in front of it. And remember, we're just counting how many I have. I have 2x squared in one parenthesis and another 1 in another parenthesis. So my total number of x squares is 3. So I have 3 x squares. I'm not going to do anything with the exponents because I'm just counting how many I have. Then my next one would be the 3x. And there's another one over here, negative 6x. Make sure you take the negative with it. So it's 3x and then minus 6x. They're opposite signs, so we're going to subtract them and get negative 3x's. Then my last one are just my numbers, the negative 5 and the 2. Again, this is a negative 5. So do negative 5 and positive 2, again, opposite signs, so I'm going to subtract and get negative 3. And then this is my simplified version of those combining those two polynomials. Yes. The exponents, we don't do anything. The exponents change when I'm multiplying them. I'm not multiplying them, I'm just counting them. I'm adding and subtracting. Any questions over that? Okay, in your pairs, do B, please. Okay, so most of us were able to come up with this. The 5x squared and the 3x squared are like terms. They're both positive, so I add them and get 8x squared. Then the 4x and the negative 6, they're like terms. They're opposite signs, so I'm going to subtract and get negative 2x's. Then the negative 4 and the negative 7 are also like terms. They're both negative, so I'm going to add them and get negative 11. If you wrote them in a different order, that's fine. I'm always going to write it in standard form, though, with the biggest exponent first. Any questions? Okay. Now we're going to go on and we're going to subtract. Subtraction needs a little extra step in there. When you subtract something, you always add the opposite. That's kind of what we're going to do here. Because there's 3 terms behind it, we want to change everybody's sign. So we're going to distribute the negative, the first step. Okay, so that's going to look like this. This negative now is going to change the x squared to a negative x squared. Then we're going to distribute it to the x and get negative x. We're going to distribute it to the negative 8 and get positive 8. Okay. Now we can just combine our like terms. So that's the next step. So now I have a 4x squared and a negative x squared here. So remember that's like a negative 1. So 4 and minus 1 is 3x squares. Then we have the negative 6 and the negative 1. They are the same sign, so I'm going to add them and get negative 7x. Finally, I have 7 and 8. They're both positive, so once again, I'm going to add and get plus 15. And that will be my simplified version. Any questions? Yes?
So why don't you distribute it to the other side?
Because it's like a negative 1 in front of that first parenthesis, and it's not in front of the first here. Any other questions? Okay. Okay, do D on your own in your pairs. Okay, Tori, what did you guys get?
I got negative 8x to the second power plus 5x
Plus 7. Do we agree, class?
Yes.
Okay, some of us do, some of us haven't said anything. So again, this should be negative 7x squared. We're going to distribute this negative. This should be a positive 2x. And this should be a positive 6. Okay, when we combine the x squared and the negative x squared and the negative 7x squared, that gives me the negative 8x squared. Then we have the 3x and the 2x. They're both positive, so we add them to get the 5x. Then we have the 1 and the positive 6. That gives me the 7. Any questions over that? Okay, now we're moving on to ones that we have to distribute first. These are problems that we struggled with on our THQ and our SRQ. Okay, so let's make sure we know how to do this. The first thing we need to do is distribute. To all terms in the parentheses. So we're going to distribute the 3x to the 2x, and 3 times 2 is 6, and x times x is x squared. Then the 3x to the negative 5. 3 times 5 is 15, and we have an x. Make sure they both, you're multiplying by the x as well. That was some of our struggles, is we would only distribute to one term, or we'd forget about an x. On the next one, the negative 6, we need to distribute that negative 6 to the x to get negative 6x. And then the negative 6 to the 7 to get negative 42. Any questions over that? Then we're going to combine like terms in the middle. So that's our next thing to Combine like terms. So I'm going to have the 6x squared. And the negative 15 and negative 6, they're opposite signs. So I'm going to, sorry, they're the same sign. So I'm going to add and get negative 21x. And then minus the 42. Any questions over that? Okay, you guys do the next ones. So it should have been positive 7x squared and then minus 14x. When we distribute this, this gives me negative 5x squared and then negative 30x. This gives me positive 12x squared and positive 16x. Combine the like terms, and that'll give you the 7x squared minus 14x. Any questions over that? Okay, now we're going to multiply. Okay, I'm going to teach you guys how to multiply using an area model. So this would be the length, and this would be the width. And so your area will be length times width. So I'm going to draw a wonderful rectangle. Yeah, it's not going to let me draw it nice and pretty. Okay, well, you'll get the idea. So the length I'm going to put here, 2x, and this part's negative 3. Then on the other one, this part is 3x, and this part is 2, plus 2. So in order to find the area of the big rectangle, you're going to find the area of all the little pieces. So we're going to find the area of each little box. So that first one, the 2x, is the length here. And the 3x is the length here. So when I multiply them, I'm going to get 6x squared. Then for this box here, this length is negative 3. And then this length is at 3x. So negative 3 times 3x is negative 9x. Then the area of this box here, you have that length here, which is 2x, times this length here, which is 2. So 2x times 2 is 4x. Then finally, we're going to have this length here times this length here. Negative 3 times 2 will give me the negative 6. The next step is to combine like terms. The like terms are here and here. So you're going to get the 6x squared. Then the 4 and the negative 9, they're opposite signs, so I'm going to subtract and get negative 5x's. And then minus the 6. So this is the area of the entire big box when I add all the pieces together. Any questions over that? Okay, we're going to do it again with h. So I'm going to draw my rectangle, or in this case, it's going to be a square, or it should be a square. So length of the side is x, and then minus 4. And since it's squared, this is also x minus 4. Then you need to multiply the sides. So here's x times this side length of x gives me the x squared. Then it's negative 4 times the x, which gives me negative 4x. Then I'm going to have this length of x times this length of negative 4 to again get me negative 4x. Then finally this, I have this length that is 4 times this width, which is 4. And negative 4 times negative 4 is a positive 16. So then I don't have the x squared just as by itself, but I do have some like terms. The negative 4x and the negative 4x. And that gives me negative 8x. And then plus the 16. So that's the area of the entire box. The more we do this, the more you'll notice that these two diagonals will usually be like terms. It won't always be, but a lot of the time they will. Okay, so just always check there. Any questions? Yes. If you can multiply in a different way correctly, I'm fine with that. Okay? As long as you can do it. That's all that I care. Because there's other ways to multiply this, and if you know how to, go for it. Okay. Okay, next one, same thing. We're going to have a rectangle. It's going to be a little bit bigger because one of the terms is now 3 terms. Sorry, one of the polynomials is now 3 terms. Okay, we'll just leave it like that. Okay, so on the top, you want the x squared, the negative 3x, and the negative 7. On the side, you want the 2x and the 5. So we're going to do the x squared times the 2x gives me 2, and then make sure you are adding the exponent. So it's x cubed, 2x cubed. Then this negative 3x times the 2x gives me negative 6. X times x is x squared. Then negative 7 times 2x is negative 14x. Watch your variables and your exponents right now, because this is where you're going to make the mistake. Is you're going to forget to square something or cube it, and then you're going to be off. The next one is going to be the x squared times the 5. Gives me 5x squared. Then I'm going to need purple. Negative 3 times 5 is negative 15x. The negative 7 times the 5 is negative 35. So the 2x cubed doesn't have any like terms, so I'm just going to write it down. The negative 6x squared also has a 5x squared, so I can combine those and get their opposite signs, so I'm going to subtract and get negative x squared. And then we also have the negative 14x and the negative 15x. They are the same sign, so we're going to add them and get negative 30x. Oh, 29, thank you. And they get minus 35. And so that's my new polynomial, the area of that rectangle. Any questions over that? Okay, let's do the next one. J is similar, but it also has that extra 2 in the front. So that just means at the end, I'm going to multiply everything by 2. So I'm going to put that around my parentheses here to remind myself. After I do all the multiplication of the 2 polynomials, then I'm going to have to multiply by 2 because there's basically what it's saying is there's 2 rectangles with this area. So I'm going to draw my rectangle again. So top is going to be the x squared minus 6x plus 3. The side is going to be the x squared minus 5. And then multiply everything together again. So the x squared times the x squared is x to the 4th. You add the exponents. Then the negative 6x times x is negative 6. And then x and x squared is x cubed. Then 3 and x squared is 3x squared. Then x squared and negative 5 is negative 5x squared. The negative 6x and negative 5 is negative 30x. And then finally, 3 and negative 5 is negative 15. Then we're going to write it all down. X to the 4th doesn't have any like terms, so I write it out. The negative 6 cubed doesn't have a like term, so I'm going to write that one out as well, negative 6x cubed. I have a 3x squared. Yes. It should be positive. Thank you. Negative 6 times negative 5. A negative times a negative makes it a positive. Good job catching my mistake. Okay. So then I have my 3x and my 5x squared. They're opposite signs, so I'm going to subtract and get negative 2x squared. Oh, this is a cubed. I put a squared. That's confusing me. Sorry. Make sure this is a 6x cubed, not squared. That looks kind of rough. And then the 30x doesn't have like terms, so we're just going to add that here. And the negative 15 doesn't have a like term, so you just put that right there as well. But like we said at the beginning, we have that 2 that we need to multiply by. So make sure you distribute that 2 through now. So 2 times 4, or x to the 4th, is 2x to the 4th. And 2 times 6 is negative 12x cubed. And then 2 times the negative 2x squared is negative 4x squared. And 2 times 30 is positive 60x. And then 2 times negative 15 is negative 30. Any questions over that? Okay, we're doing good. Okay, find the area of that following figure for me in your pairs. And then we'll find the perimeter.